Betelgeuse, a gigantic red supergiant in the Orion constellation, has captivated humanity throughout the centuries with its deep red glow and enormous size. Astronomers estimate that if Betelgeuse were placed at the heart of our solar system, it would be large enough to encompass all planets up to Jupiter. This massive star is nearing the final evolutionary stage for stars of its kind and is expected to end its life in a spectacular supernova explosion. Recently, Betelgeuse has displayed unusual behavior, with its brightness soaring by more than 50%. This dramatic rise moved it from being the 10th brightest star in the sky to the 7th. The unexpected increase in luminosity left scientists scrambling to determine whether it was an early warning of its impending demise or simply a blip in its natural life cycle. The stakes are extraordinarily high because if Betelgeuse were to explode in a supernova, it could light up the sky, turning night into day and providing unprecedented opportunities for scientific study. A star's luminosity depends on its size, temperature, and distance from Earth. With a radius more than 700 times that of the Sun, Betelgeuse has a relatively cool surface temperature, ranging between 3,000 and 3,500 Kelvin, giving it its distinctive red hue. Despite its cooler temperature, its size makes it a prime candidate for a supernova, making its current activities even more intriguing. Towards the end of 2019, Betelgeuse once again shocked astronomers by dimming to only 40% of its usual brightness. This event, visible even to the naked eye, prompted intense observations and debates. Theorists suggested that the dimming was caused either by the star being obscured by dust or by internal processes within the star. The potential of an imminent supernova became the central topic of conversation. Using the Very Large Telescope, VLT, in Chile, astronomers captured detailed images of Betelgeuse during this dimming phase, revealing that the star had developed an irregular, lopsided shape. Further analysis indicated that the dimming was likely caused by a huge surface mass ejection, during which Betelgeuse expelled an enormous amount of material into space. This unprecedented event reshaped the star, disrupted its pulsation cycle, which decreased from 400 days to just 200 days. Such drastic changes indicate that Betelgeuse is becoming increasingly unstable, raising the question of how long it can continue in its current condition. This uncertainty has led astronomers to ramp up their observations, looking for signs of the star's eventual collapse. When a massive star like Betelgeuse exhausts its nuclear fuel, its core contracts under gravity, triggering a supernova. This catastrophic explosion releases vast amounts of energy, hurling the star's outer layers into space and creating a dazzling display visible even during the day. If Betelgeuse were to explode, the first signal would be a burst of neutrinos, subatomic particles that escape the star's core and travel faster than light. These neutrinos would arrive at Earth hours before the light from the explosion. When the light reaches Earth, Betelgeuse may surpass the brightness of the full moon, casting shadows and transforming night into day for several weeks. A supernova of this magnitude would present scientists with an incredible opportunity to study the death of a star in real time. By analyzing the emitted light, heat, and radiation, researchers could gain critical insights into stellar evolution, nuclear physics, and the formation of elements that make up planets and life itself. To better understand Betelgeuse's behavior, researchers are using cutting-edge simulations to model the star's interior. These virtual models incorporate data from telescopes like the James Webb Space Telescope, JWST, and the VLT, allowing scientists to investigate the mechanisms driving Betelgeuse's erratic behavior. The JWST has provided a closer look at the material ejected by Betelgeuse, revealing intricate structures of gas and dust surrounding the star. These observations suggest that Betelgeuse may be nearing the end of its life cycle, offering an unprecedented opportunity to examine the life cycle of enormous stars. While scientists estimate that Betelgeuse could go supernova within the next 10,000 to 100,000 years, its recent behavior hints that this timeline might be considerably shorter. The astronomical community is racing to capture every detail of this cosmic spectacle before it reaches its dramatic climax, ensuring that humanity doesn't miss out on this once-in-a-lifetime event. At the end of 2023, the James Webb Space Telescope uncovered a startling new phenomenon. Betelgeuse, already in an unstable state due to its massive surface mass ejection, had undergone a rapid internal collapse. This collapse was evident through significant changes in the star's fundamental dynamics, altering the course of nuclear fusion reactions. Astronomers observed dramatic fluctuations in Betelgeuse's expansion cycles. Before the collapse, the star's surface expanded and contracted over a 400-day period. But afterward, this rhythm abruptly shifted to 200 days, indicating a significant change in the star's inner structure. This irregularity in the star's pulsation cycle resembles a cosmic heartbeat, suggesting that Betelgeuse could be entering the final phase of its stellar life. Simulations developed by astronomers show that Betelgeuse's core is becoming increasingly unstable as it fuses heavier elements. Stars that reach this phase begin producing iron, a process that marks the final stage before collapse. Unlike other elements, iron does not release energy when fused, causing the core to accumulate mass and move toward an inevitable implosion. Betelgeuse's erratic behavior has sparked heated debates among astronomers regarding the timeline of its supernova. Some argue that the recent findings suggest an explosion could take place within the next few centuries, while others believe it may still be thousands of years away. One thing is certain: the time when Betelgeuse will remain a red supergiant is quickly running out. A key indicator of an impending supernova is the release of neutrinos, subatomic particles that break free from the heart of the star just moments before it collapses. Scientists are closely monitoring Betelgeuse for any sudden surge in neutrino activity. Global instruments are on high alert, ready to detect this brief signal, which could provide humanity with its first real-time warning of a supernova. While Betelgeuse's supernova will be an awe-inspiring event visible during the day, scientists assure us that it poses no danger to Earth. However, its brightness could rival that of the full moon, casting eerie shadows and lighting up the night for weeks. This event will not only captivate stargazers, but also offer an unparalleled opportunity for scientific research. The story of Betelgeuse reminds us that the universe is still filled with unsolved mysteries. This enormous star, which has captivated humanity for centuries, continues to expand our understanding of stellar evolution and cosmic dynamics. As Betelgeuse approaches the final chapter of its life, astronomers are determined to witness and document this cosmic spectacle, ensuring that its final moments will be studied for generations to come. Scientists around the world are continuing to monitor Betelgeuse, eager to capture the moment when this colossal star reaches its final stage. The unprecedented data collected during its recent dimming and mass ejection has fueled new theories about the behavior of red supergiants in their final phases. Some astronomers speculate that Betelgeuse could be entering a stage known as pre-supernova instability, characterized by increased fluctuations in brightness, irregular pulsations, and accelerated mass loss. These phenomena often precede core collapse, though predicting the exact timeline remains challenging. As technology advances, instruments like the James Webb Space Telescope, JWST, the Very Large Telescope, VLT, and neutrino observatories such as Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are poised to play critical roles. Neutrino detectors, in particular, are essential because they provide the earliest possible warning of a supernova. Since neutrinos travel faster than light from an exploding star, their detection could give astronomers several hours of advance notice before the visible explosion reaches Earth. This lead time would allow telescopes worldwide to capture the event in its earliest moments, providing insights into the physics of core collapse and the initial shock wave. The explosion itself will be a spectacle unlike anything witnessed by modern humanity. As the star collapses, the sudden compression of its core will generate a shock wave that tears through its outer layers, releasing a burst of light heat, and energy powerful enough to illuminate the night sky for weeks. During this period, Betelgeuse could appear as bright as the full moon, or even brighter, casting faint shadows on Earth and remaining visible even in daylight. Its brilliant glow will gradually fade as the expanding cloud of debris cools and disperses into space. In the aftermath of the explosion, astronomers will have the rare opportunity to study the formation of a supernova remnant, the expanding shell of gas and dust left behind by the blast. This remnant will enrich the surrounding space with heavy elements forged in the star's core, such as carbon, oxygen, and iron, elements essential for the formation of planets and life. Over millions of years, this material will mix with interstellar gas and dust, potentially contributing to the birth of new stars and planetary systems. At the heart of the remnant, the star's core will collapse into either a neutron star or a black hole, depending on its final mass. If a neutron star forms, it will be an incredibly dense object, just a few kilometers in diameter, but containing more mass than the Sun. Neutron stars often rotate rapidly and emit beams of radiation, becoming pulsars, cosmic lighthouses whose signals can be detected from Earth. If the core is massive enough, it will continue collapsing into a black hole, an object with gravity so strong that not even light can escape its pull. The scientific impact of Betelgeuse's supernova will be profound. Observing a supernova in real time will help astronomers refine their models of stellar evolution, test theories of core collapse, and study the production of heavy elements that shape the universe. The data collected could also provide insights into neutrino physics, gravitational waves, and the structure of space-time itself. Moreover, the event will capture the imagination of people worldwide, inspiring a new generation of astronomers and space enthusiasts. Schools, observatories, and amateur stargazers will turn their eyes to the sky, united in witnessing one of the most spectacular phenomena the cosmos has to offer. For weeks, the night sky will be transformed, reminding humanity of the vast, dynamic universe beyond our planet. Even after the light of Betelgeuse's explosion fades, its legacy will endure. The remnants of the supernova will continue to expand and evolve, shaping the surrounding region of space for thousands of years. Future astronomers will study the resulting nebula, unraveling its complex structure and tracing the chemical elements it has dispersed into the galaxy. In this way, Betelgeuse's final act will not mark an end, but a new beginning, a reminder that the death of one star can sow the seeds for new worlds and new life. As astronomers await this cosmic spectacle, they remain vigilant, knowing that the universe operates on its own timescale. Whether Betelgeuse explodes tomorrow or thousands of years from now, its story continues to teach us about the life cycle of stars, the interconnectedness of cosmic events, and our place in the ever-changing tapestry of the cosmos. Delight us with its mass ejections that are dim and unpredictable. Its behavior serves as a reminder of how much we still have to learn. Its potential to go supernova offers scientists a unique chance to study the real-time life cycle of massive stars. Understanding these processes is about more than just figuring out what happened to a single star. It's about unlocking the mechanisms that form galaxies, produce the universe's essential components, and even make life possible. This information enhances our comprehension of the history of the universe and our place in it. The equipment we use to research Betelgeuse, from observatories on the ground like the VLT to modern instruments such as the JWST, has opened windows into the universe that past generations could only dream of. These technologies allow us to create simulations, study stellar dynamics, and peer billions of years back into the past in an effort to better understand the very fabric of reality itself. For scientists like Neil deGrasse Tyson and numerous others around the world, discoveries such as these ignite a sense of urgency and excitement. They push the boundaries of human knowledge and challenge us to continue exploring the universe. The next time you look at the Orion constellation, remember that one of the brightest stars in its shoulder is nearing the fulfillment of its destiny. What do you anticipate will occur with Betelgeuse? Are we witnessing the final moments of a star about to explode? Or is this just another phase in its mysterious life? Share your thoughts in the comments and join the conversation about one of the most fascinating stars in the universe. Make sure to subscribe, like, and turn on notifications for more cosmic stories that will astonish you. Until next time, keep your eyes on the skies as we observe Betelgeuse's unpredictable behavior. The mysteries of its behavior continue to baffle astronomers. Its irregularities, from sudden dimming and brightening to unexpected mass ejections, draw attention to the star's instability. These occurrences not only hint at an impending disaster, but also showcase the volatile nature of massive stars approaching the end of their life cycles. Stars like Betelgeuse present a unique opportunity for us to observe cosmic phenomena as they develop. Insights gathered from Betelgeuse's activity can help scientists refine their understanding of star formation, the forces driving stellar evolution, and the inevitable demise of massive stars. The scientific community is observing every shift in Betelgeuse's activity, eager to document any new findings that could provide clarity on when the star will reach its explosive conclusion. As the star's supernova approaches, astronomers are preparing for a cosmic spectacle that will unfold in real time, an event that could illuminate aspects of the universe about which we have only speculated. For now, Betelgeuse's behavior serves as both a warning and a beacon, reminding us that the cosmos is a vast and ever-changing frontier where even the most familiar objects can surprise us. Beyond its scientific importance, Betelgeuse also fascinates those with a sense of wonder and curiosity about the universe. The prospect of witnessing a supernova, a powerful event that could light up the sky for weeks, captivates the imagination. Such a display would not only be a visual marvel, but also offer a one-of-a-kind chance to observe the dying moments of a massive star, a process that takes place only once every few centuries. It serves as a reminder that the universe is constantly evolving, with even the most massive stars destined to meet a spectacular and violent end. Looking toward the future, Betelgeuse's explosion has the potential to significantly enhance our understanding of stellar life cycles and the cosmic processes that influence the formation of new stars, planets, and even life. The materials released by Betelgeuse during its supernova will seed the surrounding space with heavier elements, assisting in the creation of future generations of stars and planets. This chain of events demonstrates the interconnectedness of cosmic phenomena and how the death of one star can give rise to new life in the universe. We keep an eye on Betelgeuse, knowing that the mystery of its future is unfolding before our eyes. Every piece of data we gather brings us closer to answering the ultimate question: when exactly will this majestic star explode? And when it does, what will we learn from it? The journey of Betelgeuse will likely keep surprising us. As we watch the drama play out, we are reminded of the vastness and complexity of the universe, a reminder of how much we still have to discover. As technology advances, so does our capacity to observe these distant stars. Tools like the James Webb Space Telescope and other state-of-the-art observatories allow us to peer deeper into space and capture the details of Betelgeuse's behavior in ways that were once impossible. These advancements open new avenues for exploration, providing insights not only into the evolution of Betelgeuse, but also into the broader processes shaping the cosmos. The fact that we can now study a star like Betelgeuse in such detail is a testament to the progress humanity has made in understanding the universe. Reflecting on the history of astronomy, it's remarkable how much we've learned about the forces that govern the universe and the stars that illuminate it. Yet, even with all our advancements, countless mysteries remain. Betelgeuse is just one of many celestial phenomena that continue to challenge our comprehension of the cosmos. It's a reminder that, despite our knowledge, the universe still holds many secrets just beyond our reach. As Betelgeuse enters its final stages, it offers us the opportunity to witness a star's dramatic demise directly. Witnessing this event will not only alter our perception of how stars evolve, but also enhance our appreciation of the delicate equilibrium of forces that rule the universe. Betelgeuse's supernova will mark a moment of both destruction and creation. As the star's death sends elements across vast distances, those materials will become part of new stars, planets, and perhaps even life itself.